Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is the 10th problem in the differential equations chapter. This problem's a little bit tricky because it's just not that straightforward. We are given a differential equation right here. It looks a lot like an exact equation, and they actually tell us that it has an integrating factor of the form u of xy equals x to the m, y to the n. X to some power times y to some power. And what we have to do is to figure out what this integrating factor is and then solve the equation. So I'll just remind you that an exact equation has the form m of xy dx plus n of xy dy equals 0. And in order for this equation to be exact, the partial derivative of m with respect to y has to equal the partial derivative of n with respect to x. Now, if we take 3xy squared minus 5y to be our m, and if we take 2x squared y minus 3x to be our n, then we get that the partial derivative of m with respect to y is 6xy minus 5, and the partial derivative of n with respect to x is 4xy minus 3. Well, as you can see, these two are not equal, but they tell us that the integrating factor has the form x to the m, y to the n. So the question is, for what values of m and n will we get that these two derivatives are equal to each other? Well, we know that these exponents, they're just going to come out in front when we take the derivative. And we see here that these two are very similar to each other. They're both some constant times xy minus some other constant. Here we've got a 6, and here we've got a 4. Well, their least common multiple is 12. So the question is, can we pick exponents m and n, little m and little n, so that these the 6 and the 4, instead of 6 we'll get 12, and instead of 4 we'll also get 12. Well, let's think about it. In order to get 12 here, instead of an exponent of 2, we're going to need an exponent of 4. So that's going to mean that we need little n to be 2. So let's put a little 2 here. And in order to get, instead of 4 here, if we want to get 12, then instead of a 2 here, we're going to need a 6. So we're going to need to need little m to be 4, so that we get we'll get 12 when we take the derivative. So let's see if this works. X to the 4th y squared. Well, if we multiply m by x to the 4th y squared, we'll get 3x to the 5th y to the 4th minus 5x to the 4th y cubed. And if we multiply n by this, we'll get 2x to the 6th y cubed minus 3x to the 5th y squared. Alright, well then, what's the derivative of m with respect to y? Now that's going to be 12, like we wanted. X to the 5th y cubed minus 3 times 5 is 15, x to the 4th y squared. And what's the derivative of n with respect to x? It's going to be 12 x to the 5th y cubed minus 15 x to the 4th y squared. Are those two the same? Yes, they are. Alright, so we found our integrating factor. It's x to the 4th y squared. And now we just have to integrate these things. Well, let's see. Move this up. The integral of m with respect to x is going to be the integral of 3x to the 5th y to the 4th minus 5x to the 4th y cubed dx. That's going to equal 1/2 x to the 6th y to the 4th minus 1x to the 5th y cubed plus, don't forget, some function, let's call it little g, of y. Now if we integrate m with respect to y, that's going to be the integral of 2x to the 6th y cubed minus 3x to the 5th y squared dx, which is going to equal 1/2 x to the 6th y to the 4th minus 1 x to the 5th y cubed plus some function of x. Well, this and this is the same as this and this, so we can conclude that g of y and h of x are both 0. So our solution is going to be just 1/2 x to the 6th y to the 4th minus x to the 5th y cubed equals some constant c. Is that one of our answers? Let's see. Well, we have to rewrite it somehow. Let's see what we can factor out. We can factor out x to the 5th y cubed. And then we'll have x y over 2 minus 1 equals c. And that is answer